Humanity has possessed the ability to destroy itself for less than a century. Nuclear weapons, engineered pathogens, environmental collapse. The window between achieving technology and potentially ending ourselves is narrow, terrifyingly narrow. If this is true for us, it may be true for everyone. Perhaps the universe is not empty. Perhaps it is full of graves. Civilizations that rose, built, and failed before they could reach the stars. Consider what happened in the summer of 1945. In the desert of New Mexico, human beings detonated the first atomic weapon. The flash was visible for 200 miles. The heat was sufficient to turn sand into glass. In that moment, after millions of years of evolution, after 10,000 years of civilization, we crossed a threshold. We became capable of our own extinction. The time between that first explosion and today is 79 years. A single human lifetime. My grandfather was born into a world where the worst weapon humanity possessed was dynamite. He died in a world where a handful of missiles could end civilization in an afternoon. That transformation happened faster than trees grow, faster than mountains erode, faster than species evolve. And here is what troubles me. Technology does not slow down. It accelerates. Every decade brings new capabilities, new powers, new risks. Genetic engineering, artificial intelligence, nanotechnology. We are like children playing with increasingly dangerous toys, and the instruction manual is written in a language we are still learning to read. But this is not just a human problem. This is a universal problem. If the laws of physics are the same everywhere, and every measurement we have ever made suggests they are, then any civilization that develops science will eventually develop technology. And any civilization that develops technology will eventually reach this same threshold, the point where they can either reach for the stars or destroy themselves trying. The window is narrow because the progression is swift. You cannot build radios without understanding electromagnetism. You cannot understand electromagnetism without understanding atoms. And once you understand atoms, you are only a few steps away from understanding how to split them. The path from Maxwell's equations to the Manhattan Project is not centuries long. It is decades, perhaps less. So here is the question that keeps me awake at night. If this pattern holds everywhere, if every technological civilization faces this same narrow window, how many make it through? How many survive their own adolescence? When we look out at the universe, we see a cosmos that should be teeming with life. Hundreds of billions of galaxies. Hundreds of billions of stars in each galaxy. We now know that planets are common, that water is common, that the organic chemistry necessary for life exists everywhere we look. The ingredients are there, the recipe appears straightforward, and the universe has had billions of years to cook. So, where is everyone? This silence is not neutral. It is not a temporary absence of evidence that will be resolved when we build better telescopes. The silence itself is evidence. Evidence that something goes wrong. That somewhere between the first replicating molecules and the building of starships, there is a filter, a great filter, a barrier so difficult that most civilizations never pass through it. And we do not know where that filter is. We are optimists by nature. We have to be. Pessimistic hunter-gatherers did not survive long enough to become our ancestors. The ones who woke up each morning believing they could find food, avoid predators, and make it to tomorrow. Those were the ones who passed on their genes. We are the descendants of optimists, and that optimism is wired deep into our psychology. This optimism colors how we think about the future. We imagine we will solve our problems, that technology will save us, that someone somewhere will figure out how to make fusion work, how to reverse climate change, how to cure aging, how to reach the stars. We tell ourselves that humanity has always overcome its challenges, that this time will be no different. But this intuition, this deep-seated belief in our own continuity is based on a sample size of one. We have only ever observed one technological civilization, our own, and we have only observed it for a tiny fraction of its existence. We are 79 years past the invention of nuclear weapons. That is not long enough to know if we will survive them. Imagine an insect that lives for a single day. If that insect could think, It might look around at the summer afternoon and conclude that the world is eternal. The sun is shining, flowers are blooming, everything seems stable. The insect has no way of knowing that winter exists, that seasons change, that the warm afternoon it experiences is a temporary condition in a much longer cycle. We are that insect. Our entire technological civilization exists in a brief summer afternoon of cosmic time. We have been broadcasting radio signals for less than a century. We have been capable of spaceflight for 67 years. We have had nuclear weapons for 79 years. These timescales are so short that we cannot possibly know whether they are typical or exceptional, whether we are in the middle of a long story or very near the end of a short one. But we can look at the evidence, and the evidence suggests that technological civilizations face a test, a trial by fire, and it is not clear that most pass it. Consider what happened to life on Earth before humans arrived. For most of Earth's history, life was simple. Single-celled organisms, bacteria, archaea, microscopic creatures that left almost no trace. It took billions of years for complex life to evolve. Billions of years for cells to learn how to work together, to form tissues, organs, bodies. And then, once complex life appeared, it was nearly wiped out. 5 times in Earth's history, mass extinctions killed off the majority of species. The Permian extinction, 250 million years ago, eliminated 96% of marine species and 70% of terrestrial vertebrates. Life came within a hair's breadth of total annihilation. Not because of anything life did, just because the planet's chemistry shifted. Volcanic eruptions released massive amounts of carbon dioxide. The oceans became acidic. Oxygen levels dropped. And life, which had spent billions of years diversifying, nearly vanished. But it didn't. Life survived. It recovered. It diversified again. And eventually, improbably, it produced creatures capable of asking why. That is the story we tell ourselves. The story of survival, of resilience, of inevitable progress. But notice what we leave out. We leave out the billions of years where nothing complex existed. We leave out the 5 near extinctions. We leave out the fact that intelligence took 4.5 billion years to appear on this planet, and for most of that time, its arrival was not guaranteed. We think of ourselves as the inevitable product of evolution. But we are not inevitable. We are lucky, absurdly, improbably lucky, and luck does not last forever. In 1961, a scientist named Frank Drake organized a meeting at the National Radio Astronomy Observatory in Green Bank, West Virginia. The purpose of the meeting was to discuss a question that had bothered Drake for years. Are we alone in the universe? To guide the discussion, Drake wrote down an equation. It was not a precise calculation. It was a framework, a way of breaking down the question into smaller pieces that could be estimated. The equation looked like this. Un equals R star times Fp times Ne times Fl times Fi times Fc times L. Each variable represented a step in the process of developing a detectable civilization. R star was the rate of star formation. Fp was the fraction of stars that have planets. Ne was the number of planets per star that could support life. Fl was the fraction of those planets where life actually appears. Fi was the fraction of life-bearing planets where intelligence evolves. Fc was the fraction of intelligent species that develop technology capable of communication. And L was the length of time such civilizations remain detectable. When Drake first wrote this equation, most of the variables were unknown. We did not know if other stars had planets. We did not know how common Earth-like worlds were. We did not know how easily life arises, or how often intelligence evolves. But over the past 60 years, we have started filling in those blanks. We now know that planets are common, spectacularly common. Nearly every star has at least one planet. In our galaxy alone, there are likely hundreds of billions of planets. Many of them are rocky. Many of them orbit in the habitable zone, the region where liquid water can exist on the surface. We now know that the chemistry of life is universal. The organic molecules necessary for life, amino acids, sugars, lipids, form naturally in space. We have found them in meteorites. We have detected them in interstellar clouds. The building blocks are everywhere. We now know that life arises quickly when conditions are right. Earth is 4.5 billion years old. Liquid water appeared on its surface within a few 100 million years. And within another few 100 million years, life appeared. Not complex life, not intelligent life, just replicating chemistry. But it appeared fast, almost as soon as the planet cooled enough to allow it. All of this suggests that life should be common, that we should not be alone. And yet we are surrounded by silence. In 1950, a physicist named Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. The conversation turned to reports of UFO sightings. Someone made a joke. Everyone laughed. Then Fermi asked a question that stopped the conversation cold. Where is everybody? And it was a simple question, but it contained a profound challenge. If life is common, if intelligence evolves easily, if technological civilizations arise frequently, then the galaxy should be full of them. Some of those civilizations should be millions or even billions of years older than us. They should have had plenty of time to spread across the galaxy, to build Dyson spheres around their stars, to send out probes, to leave evidence of their existence. But we see nothing. No megastructures, no alien probes, no radio signals that cannot be explained by natural phenomena. The galaxy appears empty, silent, dead. This is the Fermi Paradox. The tension between the high probability that intelligent life exists elsewhere and the complete absence of evidence for it. There are many proposed solutions to this paradox. Perhaps life is rarer than we think. Perhaps intelligence is a fluke, a statistical outlier that happened once and may never happen again. Perhaps civilizations are out there, but they are deliberately hiding. Perhaps they are so advanced that we cannot recognize their technology. Perhaps they are here watching us and we simply have not noticed. But there is another explanation, a darker one. Perhaps civilizations do arise. Perhaps they develop technology. Perhaps they reach for the stars. And perhaps before they get there, they destroy themselves. This is the great filter hypothesis. The idea that somewhere between the origin of life and the colonization of the galaxy, there is a barrier. A step so difficult, so dangerous, that most civilizations do not survive it. And the silence we observe is not a mystery. It is the echo of countless failures. The question is, where the filter is located. If the filter is behind us, if the hard step is the origin of life, or the evolution of complex cells, or the development of intelligence, then we are lucky. We have already passed the test. The galaxy may be full of simple life, but empty of civilizations, and we are among the first to reach this level. But if the filter is ahead of us, if the hard step is surviving the transition from planetary to interplanetary civilization, then we are in danger. The silence is not a sign that we are special, it is a warning, a graveyard we are about to join. Look at the risks we face. Nuclear war. We have built enough weapons to destroy every major city on Earth multiple times over. The doctrine of mutually assured destruction kept us safe for decades, but it is a fragile peace. It only takes one miscalculation, one accident, one leader willing to gamble with extinction. Climate change. We are altering the chemistry of the atmosphere faster than it has changed in millions of years. We are conducting an experiment on the only habitable planet we have, with no way to undo it if things go wrong. The effects are already visible. Glaciers are melting. Sea levels are rising. Weather patterns are shifting. And we are still accelerating. Engineered pandemics. We now possess the ability to modify viruses to make them more contagious, more deadly, more resistant to treatment. We tell ourselves this research is for defense, for preparedness. But the tools we are developing could also be used to create a plague that natural evolution would never produce. Artificial intelligence. We are building systems that can think faster than us, learn faster than us, operate at scales we cannot comprehend. We do not fully understand how these systems work. We do not know how to control them, and we are racing to make them more powerful, more autonomous, more capable, because if we don't, someone else will. These are not hypothetical risks. These are real technologies in use today, being improved every year. And each one has the potential to end our civilization, not in the distant future, in our lifetime. Now imagine that every technological civilization faces these same risks, that the path from radio to rocketry to ruin is universal, that the window between discovery and disaster is always narrow, always fragile. How many make it through? If 1 in 10 civilizations survives, then the galaxy should still be crowded. We should see evidence everywhere. But if 1 in a million survives, if the odds are long and the risks are high, then the silence starts to make sense. The absence of others is not a mystery. It is a probability distribution playing out across billions of worlds. We are not looking at an empty universe. We are looking at a cemetery. There is a photograph taken by the Voyager 1 spacecraft in 1990. The spacecraft was 6 billion kilometers from Earth, leaving the solar system when mission controllers turned its camera around one last time. In that image, taken from the edge of the solar system, Earth appears as a pale blue dot, less than a pixel, a mote of dust suspended in a sunbeam. When Carl Sagan saw that photograph, he wrote something I return to often. He said that everyone you love, everyone you know, everyone you have ever heard of, every human being who ever existed, lived out their lives on that dot. Every saint and sinner, every hero and coward, every civilization that rose and fell, all of it happened there, on that pale blue dot. And here is what that photograph reveals. We are small, unimaginably small. The Earth is a tiny stage in a vast cosmic arena, and yet we act as if we are the only thing that matters. As if our conflicts, our borders, our ideologies are worth fighting over, worth dying over, worth destroying the only home we have ever known. But step back. Look at the galaxy. 200 billion stars, many of them with planets. Some of those planets in the habitable zone. Some with water, some with chemistry. The conditions for life are common. If we are here, life could be anywhere, and yet we see nothing. Now, this should terrify us, because it suggests one of two possibilities. Either we are alone, the only technological civilization in the galaxy, the only consciousness capable of comprehending the universe, or we are not alone, but no one else made it. They tried, they built, they reached a certain level of technology, and then they vanished. Think about what that means. If civilizations regularly destroy themselves, if the filter is ahead of us, then the universe is not empty by accident, it is empty by design, by the built-in vulnerability of intelligence itself. Intelligence is a double-edged sword. It allows us to manipulate the world, to harness energy, to build tools, to communicate across distances, to organize in ways no other species can. But it also allows us to build weapons, to alter ecosystems, to create technologies we do not fully understand. For most of human history, our capacity for destruction was limited by our tools. A spear can kill one person. A sword can kill a dozen. Even a bomb, in the pre-nuclear age, could only destroy a building. The risks were local, containable. But now, the risks are global. A nuclear exchange between major powers would not just kill millions, it would darken the skies, block out the sun, trigger a nuclear winter that could last for years. Agriculture would collapse. Most of the human population would starve, and the survivors would inherit a poisoned world. And that is just one scenario. Climate change is slower, but potentially more total. An engineered pandemic could spread globally in weeks. A misaligned artificial intelligence could pursue goals we never intended with efficiency we cannot stop. The common thread in all these scenarios is speed. The time between recognizing the threat and suffering the consequences is short, too short for institutions to react, too short for democracy to deliberate, too short for wisdom to prevail. This is the vulnerability of technological civilizations. We are smart enough to build tools that can destroy us, but we are not wise enough to refrain from building them. We are clever, not careful, inventive, not circumspect. And if this is true for us, why would it not be true for everyone? Perhaps the universe is silent because civilizations do not last long. 1,000 years from the development of radio to extinction. 2,000 if they are lucky. On cosmic timescales, that is an eye blink, a flicker. Civilizations appear, briefly shine, and vanish so quickly that the odds of two existing at the same time are vanishingly small. We are living in the window, right now, the brief moment between discovery and disaster. And we do not know if we will make it through. But here is the thing that gives me hope. We know about the filter. We can see it, we can name it. That awareness is not nothing. For most of human history, we did not think in these terms. We did not contemplate existential risks. We did not worry about the survival of the species. Our concerns were local, immediate, personal. But in the last century, we have gained a perspective that no other generation possessed. We can see ourselves from the outside, from space, from time. We can think in terms of centuries, millennia, eons. And that perspective changes things, because once you see the cliff, you can choose not to drive off it. There is a parable I think about often. It comes from the Cold War. In 1983, a Soviet officer named Stanislav Petrov was on duty at a nuclear early warning facility. The system detected 5 incoming missiles from the United States. Protocol required him to report the attack immediately. Soviet doctrine would then mandate a retaliatory strike. This was the scenario everyone feared, the beginning of a nuclear war that could end civilization. But Petrov hesitated. Something felt wrong. The system was new. It had glitches. And why would the Americans launch only 5 missiles? If they were going to strike first, they would launch hundreds, thousands. Petrov made a decision. He reported the detection as a system malfunction, not as an attack. He violated protocol. He risked court-martial. He bet his career and possibly his life on a hunch. He was right. The system had malfunctioned. There were no missiles. The early warning system had mistaken sunlight reflecting off clouds for rocket exhaust. If Petrov had followed procedure, the Soviet Union would have launched a counterstrike. The United States would have responded. Within hours, hundreds of millions would have died. Civilization would have collapsed. One man, one decision, one moment where a human being looked at what the machines were telling him and chose to disbelieve. This is the razor's edge we walk. The space between survival and extinction is not as wide as we think. It is not protected by laws or institutions or treaties. It is protected by individuals making the right choice in moments where the wrong choice is easier. And the question I keep asking is, how long can we keep getting lucky? We have been lucky many times. During the Cuban Missile Crisis, we came within hours of nuclear war. Multiple times during the Cold War, systems malfunctioned, and someone chose not to launch. In 1995, a Norwegian research rocket was mistaken for a missile. Russian leadership considered a retaliatory strike. Again, someone hesitated. Again, we survived. But luck is not a strategy. Luck is a temporary reprieve. Eventually, if you flip a coin enough times, it comes up tails. The filter is not something that happens to civilizations. It is something civilizations do to themselves. It is the test that intelligence must pass. Can you become powerful enough to alter your world without destroying it? Can you develop technology faster than you develop wisdom? For most species, the question never arises. A bacterium does not have to worry about nuclear weapons. A tree does not build power plants. They exist within the boundaries of what evolution gave them. They cannot exceed their limits because they cannot change their nature. But we are no longer constrained by biology. We wear clothes to survive climates we did not evolve for. We eat food grown on continents we did not evolve on. We fly through the air in machines made of metal. We have rewritten the rules of survival so thoroughly that we barely resemble our ancestors. And this power comes with responsibility. Not moral responsibility, though that matters too. Physical responsibility, the responsibility that comes from being able to alter the world at scales we do not fully comprehend. Every species changes its environment. Beavers build dams. Trees alter soil chemistry. Cyanobacteria, billions of years ago, filled the atmosphere with oxygen and poisoned most life on Earth. But no species has ever done what we are doing. No species has ever consciously, deliberately, systematically altered the chemistry of the entire planet while watching it happen in real time. We are the first, and unless we are very careful, we may also be the last. The universe does not care if we survive. It did not care about the dinosaurs. It will not care about whatever comes after us. Stars will continue to burn, galaxies will continue to turn, the cosmic machinery will operate with or without us. But we care, we have to, because if we do not make it, if we join the silence, no one will remember that we were here. No one will know that we asked these questions, that we built telescopes and particle accelerators and space probes, that we wrote symphonies and equations and love letters, that we looked up at the stars and wondered if anyone was looking back. All of it will be gone, not metaphorically, not poetically, actually gone, erased as if we never existed. And perhaps that has happened countless times already. Perhaps the universe is full of ruins, planets where civilizations rose, thrived, and destroyed themselves, leaving nothing but radioactive isotopes and ash. No monuments, no messages, just silence. We do not want to be one of those planets. There is something we have not yet considered, something that changes the equation. If the filter is real, if most civilizations fail, then the ones that survive become vastly important, not just for themselves, for the entire future of life in the universe. Think about the timescales involved. The universe is 13.8 billion years old. The sun will burn for another 5 billion years. The last stars will not flicker out for trillions of years. We are unimaginably early in the history of the cosmos. The universe is still young, still in its infancy. If we survive the next few centuries, if we make it past the filter, then we have billions of years ahead of us. Time enough to spread to other worlds, to other star systems, to transform entire planets, to become something we cannot yet imagine. And if we are one of the first civilizations to do this, if most others fail and we succeed, then the future of life in the universe depends on choices we make now, in this century, in our lifetime. That is not an exaggeration. That is not hyperbole. That is the logical consequence of the great filter hypothesis. If the filter is ahead of us and we pass through it, then we inherit the galaxy, not because we are special, not because we deserve it, but because we were careful when others were not. The alternative is silence, continuing silence, a universe that remains dead, not because life is impossible, but because intelligence destroys itself before it can spread. I do not know which future we will choose. I do not know if we will make it through the filter. The risks are real, the window is narrow. The odds, honestly, are not encouraging. But I know this. We are the first species on this planet capable of asking these questions, capable of seeing the risks, capable of making choices that affect not just our own survival, but the survival of all future life. That is a staggering responsibility. But it is also a gift. We are not powerless, we are not doomed. We are standing at a crossroads, and the path we take will echo across billions of years. The universe is watching, not with eyes, not with intention, but with the patient indifference of physics. The laws are set, the game is running, and the question is simple. Can we learn to be wise before we finish being clever? The answer is not yet written. The future is not fixed. And that uncertainty, as terrifying as it is also the only reason to hope. We do not know where everyone else is. We do not know if they made it through or if they failed. We do not know if the silence is temporary or permanent. But we know we are here. Now, at this moment, capable of choosing, and perhaps that is enough.